Okay, so in the last video, we calculated the work done by a force defined by this vector field over or on an object over this path A. And what I want to do in this video is continue with the problem and look at path B. So path B here is defined as the equation y is equal to x. Defined as y is equal to x. And just looking at my game plan again, so I have this force, and the force is defined as y in the I direction plus 2x in the j direction, okay? And I do not have dr. So what I would want to do first is to find an equation for the position r, and usually that's in terms of t, and that would be equal to some sort of x of t in the I direction plus y of t in the j direction. But you'll notice that I have no information about time, no information about how fast this object moves from O to P along this path. So hopefully I'll be able to write things in terms of one variable anyways, and I think I will. So we're looking at the path O to P. There we go. We're looking at the path O to P, and since y is equal to x, it's pretty easy to write everything in terms of one of the variables, and I'm just going to choose x. So I'm going to say over this path that x goes from 0 to 1, and y is defined as x. Pretty simple, pretty simple. So what I get from my r value is going to be r of x, and I'm just going to write it as xx, so you know that y is supposed to be x, is equal to x in the I hat direction plus x in the j hat direction. Right? That will be my r. And now I'm going to rewrite the force. So force with the same restriction, xx along this path, is equal to, it's raining pretty hard outside, hopefully you can't hear that. So the y is described as x, wow, it's getting really loud, xi, I hat, plus 2x in the j hat direction. And what I have to do now is find my dr. So I'm going to take the derivative of this right here, so I'm going to do dr dx in terms of x is equal to 1 in the I hat direction plus 1 in the j hat direction. The derivative of x is just 1. And multiplying by dx on both sides, I have my expression for dr. Right, so dr is equal to 1i plus 1j dx. Okay, so now I'm ready to write my equation for work. I have work b, wb, is equal to the integral of, let's do this color, the integral of xi plus 2xj dotted with, going with 1i plus 1j, all of that dx. So if I'm taking the integral with respect to dx, I need my limits of integration to reflect that. And I've defined my x as between 0 and 1, so that's it, 0 and 1. Okay, so let's take the dot product first. So x's times x's, or no, i's times i's, j's times j's. So we have the integral from 0 to 1 still. X times 1 is just x, plus 2x times 1, that's 2x, and this is now a scalar, it's not a vector anymore. There we go, so no i's and j's, so it's not a vector. So that's going to be equal to 3 times the integral from 0 to 1 of x dx. Alright, not so bad. So that's going to do my next step. So we have the integral of x is just x squared over 2. We're evaluating from 0 to 1, and that's just going to be a 1.5. Okay, and that's my answer. And of course it's in joules.